Good morning. Thank you for being here. My talk is how I've broken every threat intelligence platform I've ever used and ultimately settled on MISP. So a little introduction about me. I manage an intelligence team for a company, Fidelis Cybersecurity, focusing mostly on data mining, automation, feed generation. I'm a handler with the Internet Storm Center, the SANS Internet Storm Center. I am also a lecturer at the University of Illinois in information and computer science. Provide a lot of open source intelligence feeds, of which we'll talk about in this talk because it's actually relevant to this. And I run several takedown-oriented groups. A lot of what I spend, my hobby time on in professional interest is actually trying to get people put in prison behind the criminal efforts that we all know and loathe online. So a lot of my talks, I begin with this particular slide as just kind of a question of as a problem statement, right? Everybody knows VirusTotal. I'm sure people have seen the statistics page. And this was what I did Monday morning, I think, where the orange line is the more interesting one, right? It's 350,000, give or take, unique malware samples that VirusTotal saw in a given day, right? So huge number of malware samples. As many of you know, there's a much smaller number of actual families. Most of those samples, are blocky or pick whatever particular malware family you like. So there's a smaller number of families. And one of the things I try to spend some of my time on is figuring out the number between the orange and the green line of actual unknown badness that we're not detecting, which is a different talk altogether. But like I said, the number of malware tools and builders and kits is a much smaller number. And there are usually, not always, but usually multiple people using a given piece of malware, right? So if I'm going to attempt to try to say, hey, we need to put somebody in prison for something, I need to have something to disambiguate the user of a given piece of malware from the tool generally, right? Dark Comet, everybody knows that, what that tool is. Thousands of people use Dark Comet, right? Is there a way to look at data and all of the malware to get to specific individuals, right? And then how to store and represent and share that data, which is a lot of what we're going to talk about in this talk, right? And how to manage those large data sets. So the first data set that I wanted to talk about, I'm sure some people in this room use this data and are familiar with it. I create feeds based on domain generation algorithms, about 50 families, I think, give or take, where I pre-generate all the domains in a malicious DGA from 2 days ago to 3 days in the future, and then just pipe that all through DNS and resolve all of it, right, to see what resolves. Most of it is sinkholes and security operators and some goofy stuff some TLDs do. And then there's what the criminals operate, their C2s. And the idea is to get to where their command and control infrastructure is and see where it's moving over time and have that information on a relatively rapid basis. The feed generation runs every hour, right? So it provides, DGAs provide interesting kind of surveillance opportunities because at the end of the day, the criminal needs DNS to resolve, and they really can't do any games to prevent me from doing DNS lookups. To date, I've not seen it. I think it's theoretically possible where you can give a different response to a query based on the source of who's asking, but nobody really does anything. The only real case study of doing weird things with DNS is malware known as Neckers, where the resolved IP address is actually encoded, and then a mathematical formula translates the resolved IP address to what the actual C2 is. So DNS, there's another step. It's an obfuscated IP address, right? Because they're using domains, often adversaries put things in whois. They don't use whois privacy, or at least often don't use whois privacy. That provides some data that looks, that can be interesting. But the idea is let's accelerate investigations. For anybody who's done or been involved in a prosecution effort for cybercrime, it's a years-long endeavor to get to the indictment phase, right? We're not even talking about the trial. It could take years just to get the indictment. So what we can do to make that faster. like I said, I pre-generate basically a 6-day window, pipe this through asynchronous DNS, and then create feeds with it that I publish, right? And it's all CSVs, and I'll show you an example of a couple of that, a couple of feeds in a couple of slides. But it's about 900,000 domains that are generated in the list of all the malicious DGA domains, right? So it's a relatively large, I don't want to say block list, but that's how people use it. It can be used that way, and there's some implications of why you ought not to, which is a topic for another day. But that's all published as CSVs, right? Or text files, but in essence, just CSVs. There's a C2 master feed, which basically is just the aggregation of all 50 families into one file. And then I create another set of high confidence feeds because there are DGAs that use word lists and DGAs that create short domains that will often enough anyway, collide with something that's actually registered and real, some innocent victim. So I do separate out those where you can actually have some collisions with an otherwise benevolent site. So this is what the HTML looks like. If you just go to OSN Bambanet Consulting feeds, every family's got one where there's a master where it lists all the domains that resolve, all the IP addresses, the name servers, and the name server IP addresses. Those family feeds, or I should say every feed except the DGA, the full DGA list, is relatively short because I prune out sinkholes, parking IP addresses, stuff that I don't really care about, hopefully focusing just on C2s, which is important because I'll show you in a couple of slides, most people kind of take those family feeds and leave a lot of data off to the side because it's too big for people to handle and it breaks things in bizarre ways. So as an example for Tinba or Tiny Banker, a banking Trojan that is more or less quiet right now, but it's just a basic CSV, right? Domain, IP address, name server, IP address, and a comment field, right? There's only 4 really operative fields in a description, so it's very easy to represent as a CSV. People can download it, put it into whatever they want, right? I very intentionally just said, you know what, we're not going to do JSON or anything like this. I'm going to keep it simple so that it can be parsed by anything, right? What I kind of wrote in mind was something called Collective Intelligence Framework. I'll talk about that in a couple of slides, which is a good tool, but I have since broken in bizarre ways. But that's relatively easy, right? After I've done the work on DGAs, I also created a database of malware configs, where I basically statically rip configuration items out of known malware samples and then dump that in a place, ultimately shared out by MISP, which we'll talk about in a few slides. But the idea here is every piece of software has configuration items or configuration settings. Malware is no different, right? You know, WannaCry had the kill switch domain, which is an item of configuration in the malware. Most ransomware will have Bitcoin wallets in there for remote access tools and for malware that is part of an affiliate program. There'll be an affiliate ID or a campaign ID. So a lot of things can be interesting that you find in there and be useful for correlating attacks, right? Which again aids the cause of law enforcement, but it also aids attribution and some interesting research that you can do, right? Most of the configuration items in malware are not particularly operationalizable, right? You can action an IP address or a domain name. You can put an RPZ or a firewall, but mutex, I don't know why you would ever try to do anything with a mutex in malware, because generally, at least for most malware, it's randomly generated, right? There's a lot of configuration items involved. Oh, I'm going to turn off McAfee or anti-VM behavior or whatever, which is interesting, but not really operationalizable, right? But depending on the particular item, there may be ways to correlate binaries. So as an example, I brought up mutex. Usually for malware that is setting a mutex, it's randomly generated. There's no really intellectual coherence at all. But even if an attacker changes everything in their malware build, I'm going to change my C2s and campaign ID and everything else, they often will not reset mutex. which doesn't tell me anything about them except that, this randomly generated mutex will not organically occur with two random people, right? It's statistically rare enough where I could say, you know what? These different campaigns where everything else is different, they have the same mutex, and then I can relate disparate attacks to an individual and then start using that information to turn it into an identity, right? Which has been immensely useful. As a couple of examples, this is what a dark comet configuration looks like. You see typical things that you would expect, right? What's the C2 and port? There's a campaign ID. Guess 16 is the default value for dark comet. Interestingly enough, many families of malware will have some password authentication stuff in there. Dark Comet has the ability to FTP key logs, which means in the malware itself, I've got a username and a password for the attack for bad guys' FTP server, which would allow me to log in and do nefarious things, which technically are not technically, it straight up is a violation of the law, but I don't think you'd ever be prosecuted for it. But there are passwords that are associated with malware, right, that may or may not give you anything useful aside of access to bad guys' infrastructure. NJRAT is something different, right? It's some of the same things, right? There's domain, there's ports, but now you've got registry keys and different values associated with it. Right? And the point of showing those two side by side is this is just a comma-separated list of all this discrete configuration items. Actually, not all. It's about 20% of the configuration items in the database. Where if I tried to represent that in a CSV, that would be ugly. Like a 3,000 column CSV where 2,900 columns are not used, and in every particular sample, it would just shift slightly. Right? So CSV obviously wouldn't work for that use case, but there are a couple of common items that you can extract out of that. One other data set that'll be made public at some point in the future, one of my colleagues developed a tool called Yalda, which extracts out interesting pieces of malware. Basically, it goes through the process of, hey, okay, this is an attachment. We'll pull out the attachment, abstract all of the objects out of that, and then do analysis of it. Eventually, because that'll be based off of spam, that'll be an immense data set also that we'll make public and distribute, but that can't be in a CSV. But ultimately the same thing, right? We want to extract correlations of specific campaigns, right? And for that, just static IOC lists don't work. So where I started, when I started doing this kind of work 4 years ago, right? We'll call it level 1. And it's a good analogy for how most people kind of approach and mature along the process of doing threat intelligence. So, okay, we're going to do this threat intelligence stuff. I know what to do with IP addresses. I know what to do with domain names and a couple of these fields. I could probably do something with email addresses or hashes or URLs. I've got tools for that. We're going to put them in block lists. We're going to say I do threat intelligence, and we'll call it a day, right? Or I might do domain reputation or IP reputation, any number of things. Or, search in Splunk. Have I ever seen this IP address, right? And we'll call that intelligence, because the reality is of that whole list of configuration items, really only about 6 to 10 are ever going to be actionable for a SOC, right? Now, I don't do work in operations, I work in intelligence, so all the data makes sense to me. But if I go to a SOC and say, here's a list of 3,000 variables, they're going to say, I don't know what to do anything with this. Give me an IP address. I'll put it in my firewall, right? But when I started, that's what I was kind of looking at in terms of, hey, you know what? I've got a CSV. I've got 4 values. I'll use a tool called Collective Intelligence Framework, available at ccertgadgets.org. It takes basically the structure of this is to take open source feeds or whatever you may have locally, parse it all, normalize it, put it into a database, and expose it based on about 8 different fields that you would care about, right? IP addresses, URLs, domains, MD5, SHA-1, SHA-256, URLs, right? Things that we know what to do with and make it into a queryable engine, or you can generate feeds out of it. As a quick example, there's an IP address in there. I doubt anybody could see exactly what it is. But say, I'm seeing this IP address. Tell me something about it. you're going to see that I believe it's a scanner IP address, if I recall, from SSH. Yeah, scanner. It's one of the IP addresses that scan the entire internet doing SSH brute force attacks. So I see that. I know something about it, right? I can make a conclusion to say, you know what, this is probably internet background radiation, but fair enough to go put that in the firewall and block that because we don't need to do anything with it, right? And I'll give you an example of how this can be used to an effect still, right, and get positive outcomes. There was a lot of reporting, obviously, about election hacking in the United States, or what I call election-related hacking in the United States. One particular matter that I looked into was elections in the United States are done at the state level. All the local states and actually local election officials do it. Elections in the United States aren't really a federally run thing. And one of the states, Illinois, where I'm from, there was reporting that, hey, Russian hackers accessed this system, blaming it as part of the ongoing activities of the Russian government directed to undermining U.S. democracy, right? And that's how it was reported. That's how many political figures talked about it. And there's some people in the FBI that believe that. I turned around and said, okay, give me what IOCs you have. And it says, okay, we saw these IP addresses where basically pump it into CIF and said the same thing. There are IP addresses that scan SQL injection across the entire internet and have for 2 years. Are you telling me the FSB is running SQL map against the entire IPv4 space on the off chance that they might get election-related information? No, I don't think so. That's not likely, right? So I was able to make some conclusions about a high-profile stuff with that, right? So there is value. So said, okay, I've got a lot of IP addresses, domain names, so let's go ahead and put that into CIF, right, and see what happens. And it's been in there for a while, but usually the family feeds. But like I said, I created and crafted explicitly integrated into CIF at the time that I did it, right? But the family, the resolution feeds where people will point to Tinba or Neckers or whatever, right, it'll show you just the domains or the IP addresses that resolve, right? Useful information, very actionable, right? Except that, those domains get taken down all the time because there's researchers who are blocking it, or IP addresses change. All of the domains, even if they're not actively being used by the criminal, are still useful information, right? I should have access to that where I see, hey, this node is requesting this domain name. What do I know about it, right? If I'm only using what actually resolves, I may not have the answer to that question, right? So I want all the data in there, even if it's not immediately actionable outside of a response policy zone, right? So if you throw that in there, right, the GGA feed is 900,000 domains a day. Not everything cycles on a day basis, but if you aggregate that over the course of a year, all right, that's about 10 million domains. That's a sizable chunk of a database. And, the advantage is, oh, this was a domain that resolved in March 2016, right? If I saw that today, I'd be like, okay, that's interesting, right? That might give me something to think about, some potentially correlated attack, right? But I wouldn't have it operational, but I want to be able to query it. This is the actual configuration file that CIF ships using my feeds, and I doubt everybody can read it, but in the bottom 6 lines, the whole domain feed is commented out with a notice saying, you probably don't want to use this because it's too big for our system. And basically, I said it broke most people's installations because it couldn't handle 900,000 domain names a day. And about 100 megabytes of data is how big the file is. Coincidentally, until I put all of this behind Cloudflare to be a CDN for me, I was spending upwards of $600 a month just in bandwidth costs of hosting this in Amazon, right? So big data, I want to be able to query it and see things historically, but that platform kind of broke for it. But then, all right, I've got this malware config stuff. How do I put this somewhere where it can be distributed out to the community and do something, right? CIF is good for, 6 to 10 indicator types. Beyond that, You can't put mutex in there. You can't put campaign ID, and it makes no attempt to do that, right? So this is a configuration of, what, Cybergate? Nanocore, right? So I've got all these configuration items, that I'd want to take a look at to be able to query, right? Have I ever seen a given mutex before, or a nanocore sample with some of these attributes? So I said this kind of created a correlation problem. SIF has an indicator focus, and a lot of threat intelligence platforms have an indicator focus, because when people start out talking about doing threat intelligence work and research, they're really talking about, hey, indicators. If you go to a threat intelligence provider, they're selling you their information based on indicator counts, right? Oh, my feed has got 1 million entries, right? So you should pay me lots of money. Well, my feed's got 1 million entries and I give it to you for free, but I would say it's also not, the whole of all threats out there, right? So, most customers want indicators, right? Because it's a very simple metric to do, right? So the correlation problem comes in. Hey, you know what? How do I list this? I can do, hey, here are all the IP addresses associated with NJRAT. But I'm not going to be able to disambiguate anything with that. It's just like, this IP address was tied to an NJRAT sample. I don't know anything much else about everything else because I've had to discard all of that data. And that's not a good outcome. Crits was something internally we were using that kind of started to have the functionality to map relationships between indicators. You could talk about campaigns and actors. It even had some enrichments, but it hasn't really developed much in the couple of years. OTX, Alien Vaults things, a similar problem where it's got a very indicator focus. I can create pulses, but I can't create 400,000 pulses for each malware config I have, because that would probably break a lot of people who are ingesting that data. But you see, it's just kind of a bucket of indicators. Threat Connect, the same thing, just kind of a bucket of indicators, which has value. I'm not going to say it doesn't have value, but storing that in a way where I can keep at least some measure of the context just isn't available to me. Which is why ultimately I settled on MISP for the malware config stuff, where I can create an event. An event is a given piece of malware. Here's all the configuration items for that malware. I keep the raw data to do that correlation work, right? There's about 235,000 samples in there today. I'm waiting to put in about 150,000 more samples once I finish clean up some coding on my end, right? But I can't create, pulses or Threat Connect little buckets for 400,000. That would be unusable, right? And not to bag on them. The products are designed to do what they do, and I'm working with them to try to figure out a way to get my data in there just so more people have access to it. But it's unideal for that particular use, right? Then there's a notion of, hey, I could use sticks and taxi, right? I can have XML. I can represent anything in the world I want with XML. The problem is I can also represent anything I want in XML about 100 different ways, right? You just let me know when you're done with that picture. You probably want the next slide. The next slide will actually make you happier, right? So yeah, no, I never considered that nonsense, right? Product-wise, we've got to take it because some of our customers use it, but I will not willingly do anything in sticks because it is an awful, awful thing. So what I discovered I needed, right? I need something more abstract than just indicators, right? If I want to actually do attribution and correlation, right? I can't just say, hey, there's an IP address, here's a hash value, here's a bucket of indicators. That's no good, right? I have some ability to do external enrichment. I'm not going to create a passive DNS system, right? Or redo domain tools or any number of things. But there's a lot of data I want to get access to sit there and make conclusions. So for instance, for my DGA stuff, all right, there is a new IP address resolving. Is that a sinkhole that I should be whitelisting or a parking IP address? Passive DNS is great for doing that. I'm not going to create the service. I'm going to query out something like that, right? To be able to sit there and have some ability to share data with in more fine-grained control than I'm sharing to the world or I'm not sharing with anybody, right? but ultimately that context of why I'm seeing this and some visibility into the relationship of the indicators, right? Storing it somewhere where I could say, you know what, this IP address is related to this registry key in this malware sample, right? Because at the end of the day, if you're talking about, you know, a malicious event, right? It's not just an IP address or a hash value, right? It's all of these things that there's IPs that relate to domain names, to specific protocols of network traffic, to hashes, API calls, mutexes on the file system that all go into something bad that happens, and the relationship between those things is also very important. So looking at events instead of solitary indicators. This is what one event looks like in our Barncat MISP instance. You see that item there on the bottom. It's basically a JSON blob of all the configuration items of a given malware family. But you see the top, I extract out a domain, I extract out a port, hash value, some basic stuff for indexing and correlation. Not too much correlation because you know, if I correlate on malware name, well, I've got like 40,000 dark common indicators. Having 40,000 hot links to other events inside MISP is not a good user experience, but the config is there, right? So I can pull that out and I can take a look at it and I can do the work of data analytics and see what it's related to, right? There's another example of what I took as a TLP white event. So I said I could show it, right? But has indicators from there that I could sit there and go out and say, hey, do external enrichment, you know, whatever, to figure out what is going on with a given event, to do the work of correlation and actual intelligence work instead of just shifting indicators around. So why this matters, right? Taking it to, again, actually another election-related story in the United States. Around about December, just before the Director of National Intelligence released a report on, yeah, the Russians are trying to influence our elections, the Department of Homeland Security released a report they call Grizzly Steep, of what we call Fancy Bear, and say, here's all the indicators we have. Go have fun. Look for this on your network, right? Hilarity did not ensue. So for an example, from one of the, a fellow researcher said all but 2 of the hashes, you know, stated they belonged to Onion Duke, which is their name for one of the pieces of malware, but didn't have appropriate context. So nobody knew, hey, if I see this, what does it mean, right? The data also included Tor exit nodes. Why you would ever include an IP address for a Tor exit node in an indicator report, I have no idea, unless you really like false positives. And in an event when you've got a whole bunch of the American public and every member of Congress already fully rustled, not a good time to have false positives. So what happened is that somebody, a bunch of entities started looking for IP addresses that they reported, including a Vermont power company. It said, hey, Department of Homeland Security, I see one of these IP addresses in our access logs. I mean, what it really was a traffic delivery node for an exploit kit that for some reason was in the Grizzly Steep IP address indicator lists. This Vermont power company reports it to Homeland Security because somebody thought it was a good idea, leaked it to the press. Hey, the Russians breached the power grid in Vermont. No, not at all. And this power company had some pretty strong words about that because you know, they were looking, they didn't have the context. They asked DHS for context and someone decided to leak it instead for whatever reason made sense to them. Okay. So we like talking about, you know, like I said, discrete classes of data, right? And particularly in machine learning, this is a problem with a lot of the way people do it. Hey, you know, I'm going to do machine learning on domain names to find machine-generated domains. I don't know why you would keep doing that. That's a solved problem. There's tools you can download on GitHub to do that today, but people will talk about it, but that doesn't give you much. It's just, okay, this is a machine-generated host name. It could be malware. It could be ad tracking, who has the same need to obfuscate their origins as criminals do. Take from that as you will. You know, but relating that to other classes, because all of this stuff exists when somebody is breaching a network, there's more than one class of data that's involved that describes that, right? So doing machine learning off of all of those classes of data together and those relationships, at least theoretically, makes it possible to get more high quality output out of machine learning, right? So if you need to do that, right, you go over a wide variety of indicators and how they relate to one another, right? To go back kind of, like I said, to where I started, is I said my kind of professional hobby is finding a way to do something about cybercrime, and prosecuting individual actors and people behind that is good, and I'm not going to stop doing that. But ultimately, at least for the crime part of it, APT is its own world. There's an entire ecosystem involved in this, all of whom relate to each other in specific ways. There are people who write exploits, who do traffic generation for exploit kits, who traffic in compromised websites, who are money mules or carders, dark forum operators, people who have pay-per-install services for malware. And they all interrelate. And some of those relationships are reflected in malware configurations or on some of the other data. For instance, affiliate ID, right? If there's an affiliate ID in malware and I could see that there is probably more than one individual behind it, right? I know there's a marketplace. This gives me the raw tools, if I'm tracking that information, just to start saying, you know what, if we focus on this individual or that entity, we can have a larger impact on the ecosystem as a whole, right? So there's lots of pieces that go into it, right? But keeping all the context and the relationships between indicators is key to being able to do that, right? I saw this attack using this DGA seed and this affiliate ID tied to these IP addresses, and delivered by this exploit kit, right? And now I'm mapping using the technical information, right, to map the underlying economic relationships to where hopefully, right, focusing on the real pain points for the individuals or that ecosystem, so that instead of, hey, we arrested a guy, yay, wave the flag, nothing ever really happens in terms of the global volume of malicious attacks. Now, hopefully the idea is to focus on the true pain points where there can actually be impact. So, like I said, with these raw data sets, it can be marked as related to specific attacks, and you could starting to do the work of attributing actors, right? I see, I'm trying to think of another malware family, Neckers, right? And I want to attribute that, okay, if there's multiple people behind it and how things interrelate, right? I'd like to find a way to get this data in the hands of people who protect consumer networks particularly, right? And this is another professional hobby, is everybody in this room works for a company. We're all pretty well paid, I would imagine, to do that. But for home networks and home access points for consumers who make up most of the internet, we tell them, hey, why don't you go get AV and go buy an access point from whatever store you go. There's no real protection for them, right? But a lot of this stuff can be implemented at the consumer level easy enough, but finding a way to do that and to provide that protection to consumers for open data that we already have, right? Internally, we've also started the process of building a Hive Cortex MISP just to have our own internal intelligence for Fidelis done outside of what we share with others, right? So a way to keep our central body of knowledge for rules that we generate, right? As an anecdote of useful things I was able to do with this data, because the relationships between indicators are maintained, there is, and I'm being slightly vague about this for reasons that should be self-evident. There's a class of malware out there that's useful for attacking smartphones, has the ability of tracking GPS and looking out the camera and microphone, and all the typical stalkerish things you would expect with mobile malware. This software was found on the mobile device of an assassinated political figure in South America, right? All we have, okay, is a tool, there's a hash value, we've got, where the C2 was, but it's been long since gone, right? So you think investigative dead end, right? But being able to sit there and say, okay, now I have a good corpus of all the configs of this given malware, and was able to get the database of the back end of where this malware was purchased from, was able to fully attribute the individual who bought and paid for it, who launched that specific attack against that specific official who happened to be assassinated, and he became a person of interest in that particular story. And I use that anecdote because it's how many of us actually work political assassinations in cybersecurity? It's not something that comes up very often, but it was interesting that just like taking this data and saying, you know what, this would be a very interesting person, law enforcement person that you want to talk to who might know something about why your politician is dead, right? Because like I said, the interrelationship of those indicators was maintained, and then combined with other data I acquired, like I said, then it became possible to actually attribute that. So as an example of useful and interesting things you can do. It's a shameless plug. I try to build schools in Africa, in places that are hard to get to or don't have access to education. So I give this data for free and ask people to donate to a charity of which I take no income. It all goes to kids. So if you would like to do that, tomainifoundation.org. If you'd like access to my data, the DGA feeds is that OSN's Bambanet Consulting feeds thing. That's just web, static HTML. If you want access to our MISP, you can email me, give me a business card. I'll give you access to that. That is also free, but it is behind the normal username and password of MISP. Any questions that I can answer? Besides Inbar. No, it's fine.
So you made it pretty clear that the thing that you're interested in most is attribution and help bring down criminals. So that immediately means that the data that you gather and deduce has to stand certain standards of court admissibility. How do you, or what do you do to make sure that your database doesn't get poisoned by people who want to obfuscate their origin?
I guess I didn't really include a slide in that. I think there was a bullet and I just kind of skimmed past that and didn't discuss it. All of this stuff is in the control of the adversary, and actually most digital evidence is for most of its lifetime, right? If you're talking about DNS, bad guy owns the domain, he can resolve it wherever he wants. So if I'm making an operational decision, that's kind of dumb, right? If you're taking like my DGA feeds and putting the IP addresses in a firewall, you're basically giving criminals control of your firewall. And if you're cool with that, I mean, okay, it's your choice, but I think it's kind of dumb. That said, I mean, this is intelligence, right? At a certain point, it's like they can do malware config however they want, and they may obfuscate it. They may, as a rudimentary example, there's a handful of malware configs you'll see in this instance that point to 8.8.8.8, right? Google's not running a remote access tool. They've got all of our search history. They don't need a rat. They know everything about us. So it is fuzzy correlation. There's nothing that's 100% in digital evidence, and I don't think that this data has ever been directly used in an evidentiary way. It's been used as intelligence where it says, hey, this is interesting. Go file paper and get more information behind this IP address or domain name or infrastructure to get the actual evidence that would be used in court. That's authoritative, right? Because this, like I said, it's influenceable by the adversary, but it might be useful in terms of, hey, look under these rocks to get the actual evidence. So I don't think there'd be a scenario where this would actually have to stand up as scrutiny to court. It's just making sure that, if you're doing the work of investigations, you have the right expectations of knowing that, hey, DNS is an example, right? That's in the control of the bad guy. They can point it wherever they want. Anyone else?
Any further questions? Oh, okay. Thanks very much, John.
Thank you.